It's going to be a longer deep dive into the map programming that we've got. Now, let me just get my OBS set up so I can make sure we're not lagging or anything like that. And then I'll get chat on screen just in case. Okay, we're going. All right, welcome back to the stream. So this is my stream. It is a game development stream for beginners by a beginner. So hopefully what I do can help you start your own game, because I was getting a little discouraged watching all my favorite streamers and everything they'd say just went right over my head. So I like to try to explain what I'm doing so that hopefully people can follow along. So let's get started here. Yesterday what we did was we made it so that we can index into all of the tiles in our map, grid, whatever we want to call it. So like one frame of playing is all of these different sprites. So we have complete control over what to draw now. So that's good. Now the next thing is, and I can show you if we go into here, this was not the right thing I wanted to do. If I go into here, okay. Let's go into our project here, and we'll go into what we did yesterday, which should be in our play state. We are in our player class, so in our play state we have map 3.3 and map 3.4, which is just a table of all these constants that we give. So if we want to render a different level, we can go map 3.3, and now we have this other map. So the goal of this episode is to hopefully start implementing the transitions between the next level, right? So we've got one right there, and then we can go into 3.4 here, and that's the second level, but we want to make that a transition from going from left to right or from bottom up, however we want to do that. So yesterday we kind of played around with this translate function, which scrolls like that, which is the start of it. Yeah, you know, aka Bob, I've been thinking about doing, I know they do, some people have those little streams starting soon, and that's how they start the stream, and then they pop on. So I might do that. I know Streamlabs offers that, but I'm not on Streamlabs, so I don't know how to pull that off. But anyways, we're here. So we've got this, which is great because it translates, which is like what we want when we walk off. But what we don't want is our character to scroll off. And yeah, I'm sure I'll be able to figure it out, aka Bob. It'll just be a matter of time. I've been getting up to speed on Twitch pretty quick here. So hopefully by the end of today, we can do a translate that looks good. You know, a transition that looks good, and it moves the next map onto screen, and it doesn't move the HUD, right? Because right now it's scrolling everything, including the HUD, which we don't want. So we will have to split stuff up. So this is a big undertaking because I haven't done anything like this before. But the good news is we've got something to reference, and what we've got to reference is, if we go into our other repo we were taking a look at yesterday, which was called Zelda, I think. Zelda from the CS50. Yeah. So the CS50 game dev course offers this. Let me see if I can. If we go into here, yeah, we have a new harpoon. Okay, so that's good. So what we can do is harpoon a bunch of these files. Now, I thought I had set up a way to resize my Tmux windows here but I'll just kind of move it like that for now. I thought I have a keyboard shortcut for that, but it's not working, so. Okay, so they're doing a bunch of stuff that we don't have the ability to. For right now, I'm just gonna mute the sounds so that it doesn't keep making music at us. But let's check out their transitions here, right? So you walk around and you get to open the gates, and then when you walk through a gate, it goes over to the next map, and it spawns all these little entities, and it doesn't matter which way you go, the screen will translate appropriately, and your character still moves. So that's right now, our character just kind of moves with the screen, so we need to fix that. So we're gonna be looking at how they do it here, and trying to implement it for our own game. So what's cool about this is we can kind of peek around, right? So we can say, I think in their, look at all the stuff they've got. So they've got all their animation stuff separate out in this, which we want to do something similar, because we don't want to have to code a timer for every single sprite. We just want to say, hey, just run, inherit our animation class, and the animation class will keep track of the time that it's spawned. It'll keep track of what frame you're on, whether or not you're looping, and then it'll handle all the updating and rendering so that we can kind of abstract that away. So we want to do that eventually. And then they've got this whole entity class which gets like an X and Y position, and then all the collision, which we ultimately want to do at some point, but not right now. We don't have any entities other than our player, so we're not doing that. I think the most interesting stuff, if we take a look at what they call a dungeon. So dungeon here is a class, and it takes in a player, and here's what we need to implement too. It's like there's this current room, right? Hey, Saltamanga, good to see you, dude. How are you doing? Hey, I liked your YouTube video. I just watched it. It's really good. We've got a reference to this next room as well. So that's going to be important, because we need to know what frame we need to render, and then we need to know what frame we need to render on screen to transition us out. So we'll need to do that. And then this is the really cool part of what they've got going on. And they've got this event listening function. Now, we don't even have this capability yet, because this is from a knife module. The module itself is called knife, and it's got a bunch of different stuff. But what this does is allow them to say, hey, listen for this event called shift left. And if it is, run the function begin shifting. And then you give it the 2 parameters. So let's go take a look at that function, which is begin shifting. It takes in 2 values, a shift X and a shift Y. So this is what they're using to translate the image off screen, right? So it's got a finish shifting function as well, but the important part is right here. They've got this timer.tween. Now, tween stands for, no way. Sekiro Instagram liked your art on there, Saltamanga? That's really sick. That's super cool, dude. That's awesome, congrats. What's cool about this timer tween function, so this tween stands for between values, right? So it's like, what this is doing is, this is actually a time. So this is 1 second. And what it's saying is, hey, we want to modify our camera X value to become our shift X value over the time of 1 second. So what happens if we change this to 5? Look what happens in their code here if we change that to 5. Instead of 1 second, it becomes 5 seconds. So now we can slow it down and see that transition in action. So that is really cool, and we need to be able to take advantage of that. So we'll need to use something similar. Now their stuff is a little different. So like, if you look at their stuff, the only movable grid is right here in the very middle, and there's like 2 tiles on either side. So we we can't just use the same-ish code that they've got because they're rendering stuff differently than we are. So what we can do is kind of use what they did as a template to get those tween values and see how they shift one dungeon to the next and maintain the same position for our player character as we move from screen to screen. So hopefully we can figure out something like that. And that's going to be fun. So it's going to be tough because they've got a whole bunch of stuff going on and that's what's so tough. Like, I used to think reading code was like reading a book. Like, if you read one sentence, you're like, oh, I know what that sentence means. But with code, it's like, yeah, one sentence, it tells you exactly what it does. But in the grand scheme of things, you don't know what it actually does until you know what the heck a dungeon is, how it's used in the main function, all that stuff. See how it all applies to everything. So what we do know is we need to use some module to tween our values, right? So if we do something dramatic like 10, we can see that there's actually some more interesting stuff going on with theirs. Is like, look at the player, it's walking at normal speed. So everything is super slow, but it's walking at normal speed. And they're also doing this stencil rendering. See how he walks under that tunnel and the shape of the tunnel was still kind of covering him? We're not that complicated. We're just going from screen left to screen right. So hopefully we can figure out how to do it. So I guess the first thing we need to tackle is we need a way to save our different grids. And then I guess we need to both translate our current grid off and our next grid on. So we need something that can handle holding, 2 grids worth of data. Because once we begin shifting, and begin shifting is triggered with that event listener, which is also a knife submodule or module. So we need to have some collision detection for ours, for our left side, right side, top and bottom. We need some collision detection for when we need to trigger a transition. Then we need to write the transition function for begin shifting, which pauses all the update function for every entity and other thing in the game. And then a finished shifting, which kind of, I guess, resets the next room to be a potential next room to be scrolled on. And then I guess at that point ours is going to be a little simpler because we have just like a full grid. The only thing that's different is we have the HUD that needs to not scroll. So we need to do that. And you know what? They've got it too. Like, look at the hearts. The hearts at the top left don't move. Everything else scrolls. So we can take a look at how they did that. If we happen to know the code base, where would it be? In PlayState? PlayState render? Yeah, so check this out. So they're doing, maybe it's not here. Oh, it is here. So look, they do this where they render the dungeon, and then outside of rendering the dungeon, they render this stuff on top. So they do that in the play state, and we don't have, almost all our stuff is in our play state at the moment. But if you look at theirs, it's super, look at how clean that is. So they're saying like, hey, give us a player. It's got these animations. It's got this walk speed. It's got an X and Y. It's got a width, a height. And then they instantiate the dungeon. Then they instantiate the room. So let's take a look at their room function. Now, what's really cool is, you see what I did just there? I moved my cursor onto room, and then I typed GD for go to definition, and it just opened up the room.lua. So that's a LSP function in NeoVim that allows me to kind of hop. So it's like, if I'm in some class, I'm in the room class now. I'm like, what's a doorway? I can see GD, and then now I'm in the doorway class. So now I can look at that function. So it's just a cool way to hop around. So that's one reason I really like NeoVim, and the ultimate like configuration you got going on with it. So let's take a look at the room class. Now they've got a map width and map height, and map width and map height is like the actual walkable area for them, not the black borders that they've got. Then they populate their entities, they draw their they populate their walls and floors. They insert all the doorways. And then I don't think we'll have to do something like this. They do this render offset X and Y because their map is in like the center of the screen and it doesn't extend to the corners. So I don't think we'll have to do that. They generate entities. Okay, so like a room is like all the stuff that's in the room, whereas what a dungeon is what they're calling a current room and a next room. So we need something like this where we can say we need, I guess we call it like grid, or we call it a scene or something, like what's on screen for us. So if we switch over to us, and you know what, let's turn off our, oh, see, I do have that shortcut working. We turn off that translate in our player class. Is it player? No, it's here. It's got to be here, just at the top. We turn off this translate, we won't scroll off, and then we can just kind of take a look. So it's like all of these sprites that we're rendering are part of what we call as a map, right? So like we call it a map width, a map height, and then a map at a current grid. So we need something similar in the sense like we have, I guess, a map object at the moment is literally just a table of all the indices. So we need something that can keep track of, we need our dungeon equivalent, right? So like for them, they have a dungeon that is kind of holding the info of, hey, this is our current map, and once we initiate a transition, we need a reference to the new map that we need to render on. So we're going to hold both of those details so that we can scroll one off and scroll one on at the same time. So we need to come up with something that can hold that, because right now our map is literally just a table of all these constants, which doesn't help much in terms of the logic of rendering stuff on and off. So we'll need another class, maybe I was thinking about calling it scene, like this scene and the next scene, because when you move left, you know, the scene from the left will move onto your screen. So maybe we call it scene. And then whatever our current stuff is, we just call it like a grid. I mean, it's really just a map at 2-index. It's a 2D array of our map table. We might change that. I don't know. But we need a class called scene so that we can say, hey, our current scene is map 3.3. Our next scene is going to be this map 3.4. And then once we trigger the detection of the edge, you know, let's say map 3.4 would be the third column, or third row, fourth column. So once we detect a right scene transition, we can trigger a begin shifting for the next scene, and then we populate the next scene as the thing that we're rendering on screen. I think I understand how to do it. It's just tough. Man, I swore there was a... I've got the keyboard shortcut to lengthen it on the other side, but not to scoot it the other way. So let's dig around a bit more in their dungeon and see if we can figure something else out. So like, let's take a look at their begin shifting, right? So we can say begin shifting, and I can't find it. Maybe it's begin shift. Okay. So this is in their dungeon class. So I'm thinking our dungeon class equivalent is our scene class. And then once we detect this shift left, so we'll need to import our knife module so that we have this event listening. And then they just write this function to call begin shifting, give it 2 values, and then here's that function. And what they're doing in this function is saying, hey, we're shifting. Here's our next room assignment, which depends on which direction we're going to be shifting. And then they set all the doors open to true. They get this shift X and shift Y for our next room. And then they tween it with the shift X and the shift Y here. So if we take a look at how they're rendering this stuff, they should be rendering it with the camera X and camera Y, which they are. They're actually translating the camera X and camera Y. And then here's the kind of interesting part too, is they're only translating it if they're actively shifting, and then they're only updating it if they're currently not shifting. So that's what gives the effect of all the enemies stand still when they're shifting screens, and they update whenever you're not actively shifting. So it's a lot going on, but as soon as we figured this out, we've got most of the ugly kind of homework part of getting the game done, because it's like once we can get the screens moving in the right way, then we just have to worry about what to fill those screens with, and then all the mechanics. That's all the fun stuff. This is all like the nitty-gritty. How do we tell the computer in a pretty way what we want it to do for the whole map and movement system? And then once that's figured out, it's going to be a lot smoother sailing. So let's get to it. I got little Ghirardelli Valentine's. Oh. Sea salt caramel. Okay. Let's take a look at the module, right? So it's called a knife, and it's in lib. So knife is all of these things, and if we actually take a look at our main, if we go to the top here, actually it's just in dependencies. So if we go into our dependencies, we'll see that they're actually only using 2 modules from this knife. They're using this knife event and this knife timer. Now the knife timer I've seen used as the tween values, and then the event is the event listener. So they're actually only importing 2 of these modules. So let's take a look at those modules. So they've got event and they've got timer. So this is the code for the timer. I'm not about to understand it. But look, they've got all that tween stuff. Let's maybe take a look at the timer.tween. If we search for tween, we've got update tween, plan tween. I guess I don't get how they were able to say timer.tween and then give it the table. Like, I don't see a way where it's kind of telling you what those parameters are, but we can use it like they use it, and it would hopefully work. So the other one they use is event. So this is the event handler. All they're doing, I don't know what they're doing. They're doing all this junk. All said and done, it's not a crazy amount of stuff. You know, it's only 100 lines of code. But I don't know what a lot of this stuff does. So like, I don't know. I can tell you what this code does just by looking at it. But if it functions like it functions in the CS50 game, then we'll be able to use it. So I guess the first step is for us to import this knife module, and then we'll work on making our scene class where we can hold a reference to our current scene and the next scene. And then we'll attempt to render our current scene and our new scene, tweening these values with the knife timer function. So if we can do that, then we can die happy. So let's go back, and you know what? Let me quit. I don't want to. I'll just kind of minimize this over here for now. And what we'll do is we need a scene class to hold all these things. So let's go ahead and go into our classes, and we'll make a new class, and it'll be called scene.lua. And when you make a class, you need to tell it, hey, scene gets I'm forgetting how they even do it. It's just, is it I want to say it's a table with squirrely braces like that. And then we have 3 functions we need, which is a scene init, and then we need a scene update. So we give ourselves scene update with delta time, and then we need to give ourselves a render function as well for our scene. And then we can say scene render. That'll be our render function. And then let's double check that if we go to our player class at the very top, player gets class with squirrely braces. So we did it right. So right now we've got that scene. Now, are we, I don't think in our main we're actually, we're requiring our dependencies, and then in our dependencies we need this scene. So we'll require our class for our scene, and then we shouldn't crash when we run the game at least. So, okay, so I guess the first thing we're gonna do is try to import that knife module so that we can get the tweening working for the camera shift. Then we'll work on those functions. So it'll be easier for me to do it on the computer here outside the terminal, for us to go into our Zelda function or Zelda folder and go into our library and get our knife module. So let's make us a lib folder in ours so that we can put stuff like this. I don't know what the shortcut is for make a new folder. Shift N maybe? No? Nope. Okay, well, we'll just make a new folder. Oh, Shift Control M. This will be lib for library, and we'll put in our knife module. So now this is someone wrote this. Their GitHub is on the repo. I feel like they might have their stuff typed out in here, but I don't know. So let's make sure we import this lib knife so that we have access to it. And we'll go /lib/ and you know what? They actually do it different. I'm thinking now how in their if we go into their knife, see how they do it different? They go how do I do that? Okay. They kind of save it in this variable here. So they say event, the global variable event gets that require lib /knife dot event. So I think that dot notation is just a way of saying inside the knife folder, the event Lua becomes saved into this event variable. We'll see if we crash. We'll try to run this for as soon as we save this and see if it doesn't know what I'm talking about, because I've never used that dot notation in a file path like this. So lib /knife dot timer will get put into our timer variable, and that's how they do it. So then they call event dot on or whatever it is for that listening to begin a transition, and then they do a timer for the tween. So let's see if we just crash. You know, we work, so we don't crash. That's good. Now I'm gonna search for this event and see when they use this event in our player state or dungeon. Probably in the dungeon, yeah. So right here they've got okay. So they've got event.on, and they pass in the event, and then they give a function to be called. And then I guess let's take a look at their timer, which they use where for this. It's like a timer dot. Where do they do it? Oh, we'll need to do that too. I want to see where they do the tween. So they say tween. Tween the value, and then they do it right here. Timer.tween. Okay. So that's the variable that we just assigned. Timer gets the module, then they're calling it by just saying that variable .tween, and they give it two things. They give it a time, a duration as an integer, and then they give it a table of things to tween. And each table could be a table. It's like an index to a table, and then they shift multiple values. So it works a lot. You know, Salto Manga, favorite 2D game. I love Link's Awakening, man. I mean, that's Link's Awakening did it for me, and of course, Pokemon Gold and Silver. Those are just like my childhood games. So of course I love them. What about you? I mean, that's why I'm making this. You know, I've always wanted to make my own Link's Awakening, so I'm finally doing it. And then I'm pairing it with a favorite book of mine, so I think it's going to be really fun. Okay, that's going to be tough. Okay, so before we forget, let's do what they do, and they update their timer. So if we go look at their timer in their update function, they literally just say timer.update gets delta time, so that they can do that. So let's do that in our main.lua before we forget. So we'll go into our main, and we'll go into our update, and we'll just go ahead and update our timer, give it delta time so that we can actually tween those values, because that would be a hard, you know, Blasphemous was really sick, dude. I don't think I beat it. I got really far, and it was really great. I didn't beat it though, but I really liked it. Love the art style, love the gameplay, all that stuff. It was a tough game though, for sure. I'm still stuck on Metroid Fusion. I can't beat the last freaking Ridley. I can't beat it. Okay. Let's take a look at their dungeon again, and then we'll see if we can't piece together our scene. Dude, I know, and you have to kill him. You have to kill Ridley after you kill the other super, the other super suit, and it's just like the super suit's hard enough, and then you have to kill Ridley after that, and it's like, I would have never been able to do that as a kid. I can't even do it right now. Still working on it. Okay. So in their dungeon class, that's where they're actually passing in the player so that they have access to the player. So that's smart. And then a current room and a next room. And then they initialize the next room as false, first of all. So I feel like our scene would need to... I guess we have to see when they instantiate this dungeon, because we need to see what part of the game they're doing that, because we need to give our map, our 2D array map, we need to be giving to this scene function. You know, Stardew Valley, I liked Stardew Valley so much that I made myself stop playing it, because I would wake up, I would go to bed playing Stardew Valley, and I'd wake up and I'd play Stardew Valley. So I just, I had to stop, because it was like the only thing I liked to do. But yeah, so Stardew Valley gets props for sure. I mean, there's a ton of awesome games that I could reference, but so crazy too that Stardew was made by one dude, right? Like that guy worked at a movie theater, and then his girlfriend, you know, helped him pay. Yeah, helped him pay the bills while he just sat there for 6 years making Stardew Valley, making $1 billion. That dude deserves it. I follow him on Twitter, and he's making a new game about like a cookie machine or a candy factory or something. I'm excited for it, obviously. Let's see where they instantiate this dungeon. Because if we do a dungeon and then open parentheses, we'll see that they put it in their play state. So they say their play state gets a dungeon field of a dungeon instantiation, and that dungeon instantiation is the one that's holding the reference to the room and the reference to the next room. So we need to do... But then they're also referencing the current room here in the play state. So I'm wondering if... Yeah, that's kind of weird. They reference... So they've got a current room, a .current room in their dungeon, but also a .current room in their play state. So I wonder what the difference is that they're doing there. Okay, well... Let's go to our scene, and we'll try to implement the tweening for our scene either through a event listener. So the other thing I want to check, I want to see when they call that event listener, right? So like they call the event on here in the dungeon. So if that is in our scene class in our update function, then we can define these shifting functions within our scene class, and then maybe we can start getting some stuff rendered. You know, I had so much fun with Goddess too. Like, after Curiosity, the hype for Goddess was real. Okay. So yeah, let's go into our. We'll start building out our scene class, and we'll build it kind of like this, in the sense that we're going to be giving a reference to the current room, and the next room. But we need to do. Where is our. And they build it out differently. They don't have a folder called classes. They have everything kind of. Yeah, dude. You know, so my uncle worked at Nintendo. My uncle actually worked at Toys R Us, and he got us, got me and my brother a promo release of Pokemon Gold and Silver. So I still have it, and it's the I had Silver, and it says not for resale on the front because it was like for a Toys R Us promo. So, you know, I'm a Pokemon Silver boy all the way through, but we obviously, you know, played each other's games and wrote over each other's file. And yeah, dude, my uncle worked at Nintendo, I swear. No, he worked at Toys R Us, but he hooked us up, and it was like, and my memory's a little iffy because I was a kid, but like in my mind, I got it before the game was actually even out. But I don't know if that's true or not, because I didn't have Pokemon Blue or Red. I was a Pokemon fan from the show, but we didn't get the cartridges until the Pokemon Gold and Silver came out. It was awesome. So yeah, Pokemon's another big, you know, I want my game to have similar aspects that Pokemon does, you know, of the kind of, I don't know if you want to call it Metroidvania or whatever, but like if your Pokemon knows strength, you can move the boulder and you can get to these parts of the map that you couldn't otherwise get to, or you can cut down that tree or spray bottle the Sudowoodo or whatever but like as you get more powers, you get more, you know, access to the further levels of the game. So I'm excited to get into that part of my game, but we gotta build the freaking transition first. That's the real hard part here. We'll go into our class and we'll go into our scene and we'll start building this out. So like, we do need a reference to our player. We know that much. And our player is gonna get the input of the parameter player up here. So that'll be the first argument. And, you know, the game I'm calling Kvothe DX just because I didn't want to have to type in the name of the wind in my Git repo. I just, so I made it a shorter, like Link's Awakening DX, because that's the first one I played. I just did that. But if I have a title screen, it'll probably say the name of the wind. It probably won't say Kvothe DX. So that's just the name of the repo because it was shorter and I didn't want to type that many words. But yeah. If we give ourselves a player parameter, we need to give in a current scene as well. And then what we can do is we can say that our self.current scene gets the parameter that was passed in. And then we also need a next scene that we will initialize. Yeah, you know, I never beat Wind Waker either. I never had a GameCube. So I only played it until... I didn't play it until I had the remaster on Wii, I think it was. And then I never beat it. I loved it. I thought the style was awesome, but I just never got around to beating it. I haven't beat Tears of the Kingdom either yet. but maybe one of these days. It took me like 8 years to beat Breath of the Wild because I was doing Master Mode. And I was trying to do the Master Sword Trials on Master Mode, and it took me multiple years to get the freaking Master Sword Trials. Okay. We'll initialize this next scene to nil. So next scene gets nil. What else are they doing? They've given themselves a camera X, initialize it to 0. Yeah, I only ever had friends that had a GameCube. Like, I remember the day Sonic DX. Is that another DX game? Sonic DX? Yeah, Director's Cut? Or what was that? Was that called Sonic DX? Does chat know? You know what I'm talking about? The Chaos Emeralds, the GameCube one? Was it really DX? That's another DX game. I remember the day that came out. We went to the store, and my friend's mom bought it for him, and I was like, bro, you have a GameCube and your mom's taking you to GameStop to come get the new game right away? Like, that's so freaking cool. Then we played the shit out of that game that night. So we've got a shifting boolean that we start as false, and then I guess it's kind of interesting to me that they do this event listening in the init function, and then it makes sense that it's in the init because you're not listening for. I guess it's like if this gets triggered. I guess I don't know enough about the knife module to know how this works, but event on shift left, then they're going to begin shifting. So how do they get away with putting that in the init function and have it work even after the game is working? Like, because the init is supposedly only called once at the beginning, right? But I guess I don't know how it works, but it clearly works. So we can do something like that where we say shift left of our event listener gets to call this function, and the function that we're going to call is our begin shifting, and then we need to give it 2 parameters, which I don't know at the moment. That's kind of our template for these event listeners, and we've got shift right, and we've got shift up, and we've got shift down. Okay, so the only difference between their function calls here is the values that they're giving their shift X and shift Y parameters here. So shift left, it gets a negative X. Shift right is a positive X. Shift up is a negative Y. Shift down is a positive Y, which all makes sense on paper. Dude, yeah, that's awesome. We got the PS3 on launch for Christmas, and we had a Blu-ray player. Like, it was so sick. That we missed out the whole PS2 era. We didn't have PS1. We went Game Boy. We had the NES, so we were playing Zelda as kids and Duck Hunt. And then we got Game Boys. So we got the Game Boy Color, Game Boy Advance, Game Boy SP, and then we didn't have a console until PS3. I think that's right. No, we had a Super Nintendo. We had a Super Nintendo because we played Donkey Kong Country like motherfuckers. Okay. Then outside this update function here, that's where they define these actual shifting. So we're going to say scene begin shifting, and this is where they put in those those parameters to use. So they're saying shift X is the first parameter, shift Y is the second, and then if we begin shifting, then our self-shifting gets true. That's the first thing they do. And then they assign their next room to be equal to, and this is a little weird, they had, what they're doing is putting a room instantiation as the next room, but I don't see how that actually populates it with what they're trying to do. Well, I'm going to take a look at their room class here, and you give it a player, and then it'll generate. Oh, okay. So they do it differently. So like they're doing this function called generate walls and floors, generate entities, generate objects, because every space is a new random room. So all they're doing is just instantiating a room, and that's literally just gonna be the next room. It's just a random room. Ours is different. We need to detect what scene we're transitioning from, and then whatever side we're going into, that's gonna be our next room. So we need to figure out how to explain that in code, which isn't so easy, but we'll figure it out. So next room, and for now we'll just put this like Tim the Toolman Taylor question mark in here. And then I guess for now I'll actually comment this out too. Okay, what else do they have in their begin shifting? They've got adjacent offset X, which I'm not exactly sure what they're doing with that. Let's see if they say, where do they use this? They use it, they assign it here, and then they reset it. But I don't really see how that helps them. They're not using it anywhere. Offset depending on which direction we generate the room. Okay. So they're just... Yeah, Splinter Cell's a good one, man. Splinter Cell's really cool. Hey, you guys, if there's 5 people in chat right now, comment, we can get an achievement for the channel. Five people chatting at once. So I'll pitch in if you guys pitch in, like because it's not often I've got more than a couple people here, so if we can get 5 people chatting, we get that achievement. That would be nice. I don't know if you guys noticed either that I'm streaming in 60 FPS today. That was a product of paying $30 more a month for Xfinity to give me the upload bandwidth. Yes, let's get chat going. Let's get this 5. This is really tough, y'all. We're trying to do so many different things here, and all things I've never done before. For right now, I'm going to leave off our adjacent offset X because I don't see how they're actually using it. I see that they're storing... I see that they store, you know, the parameters that they pass in there, but I don't see them actually use it. Oh, well, next, it's a field of the next room. Okay. Yeah, I know, my bandwidth was so crappy my bandwidth was so crappy streaming in 1080, I could only get 3,000 kilobits or 3,000 megabits a second for the stream. But now we're sitting at 60 FPS at 6 megabits. So hopefully it's looking good and I can do stuff like this and you can still see it okay. What's really important is that you guys can see like my number inputs and everything. Or you know, if I do this, that you can see what direction I'm moving in and everything. Like that's what's most important to me. And it should look better for you guys. So yeah, man. Okay. Where do we go from here? We've got our begin shifting function. We need to do stuff with our shift X. So here what they're doing is saying if our shift X is positive, then we're going to set our player X to be the right position, because when the whole scene is transitioning, we need to tween the player value from where it leaves the scene to where it ends up in the next scene. So if it walks off screen to the left side, it's going to end up on the right side of the next screen. So the tween value needs to, you know, we need to know which way. And they do it here, like they do it right here. This self.player table, they shift the player's X, to be player X, which is what they decide right here a couple lines before, and our Y gets player Y. So this is how the tween function works. I think it takes one value of one table. So since when we instantiate our camera X, it's a self.camera X on the dungeon class. So it's taking that variable and it's getting assigned the new variable. And then the tween function will turn that first variable into the second variable over that amount of time, which is the first argument here, so over 10 seconds. So we need to be able to say that we need a player X and a player Y, depending on the shift position. So once we put in our proper parameters here to our see how this is negative, so shift X is negative, therefore they're doing a shift X is smaller than 0, which means that their player X is going to get a negative virtual width plus map render offset X plus map width times tile size minus self player.width. So like we don't need to do all that crap, because we're not doing this map render offset because our map is actually just all the way to the side of our screen. So hopefully ours can be similar to that. But like I want to just get it working. I want to get something working for our tweens so we have something to troubleshoot for tomorrow, because I doubt I'm going to be finishing this tonight, finishing the transitions. I guess let's keep looking at let's go ahead and we will give our shift X and our shift Y the same parameters here, at least as a starting point, so that we can potentially test things. So we'll say virtual width minus virtual width if we shift left, meaning that our shift left is going to end up at a negative virtual width. Is that right? Negative virtual width. See? And I don't know if that's in relation to the current room or the next rooms. So that's confusing me a bit. But if we put virtual width positive and 0 for that, minus virtual height. Yo, thanks for watching the stream, guys. This is cool. They're, you know, for Twitch affiliate, they require average viewership of 3 and 50 followers. And I think I'm sitting at like an average of 2.3 or something like that. So a stream like this is helping me get those numbers up. Shift down is a positive on the Y. Shift up is negative on the Y. That makes sense. And then if we take a look at what they actually do with the Shift X and Shift Y, they assign it into the next room, which I don't quite get. I don't get why they go into the next room and assign the adjacent offset X and Y into that. I don't know why they do that. Let me see their self room. It's next room. They started off as nil. Once they finish shifting, they put their next room into the current room. Okay, so did you watch was that the what was it? The Paul Dano one, right? Is that the one you watched with the GameStop? Was it Paul Dano who played Roaring Kitty? Dude, we got ripped off at GameStop, man. I'm so sad that we would bring a stack of 10, 15 PS2 games and they'd give you $10 store credit towards a $40 game. Like that was jacked up. Because as kids, you don't have freaking money. All you have is your old freaking games and they just gouge you. So they populate the next room with this adjacent offset X. Not initially, but once they finish shifting, they go into their next room. Okay, so I think this adjacent offset X might be key to rendering the next screen onto our previous screen. But I don't know exactly. Yeah, I want to see that. I wanted to see it in theaters and it was down to one showing and it was like a work night and I just didn't go see it. Okay. So let's go ahead and do our Shift X modulations here. So like if our Shift X is smaller than 0, meaning a shift left event has happened, then we're going to say that our player dot X, and we since what we're putting in player is a Kavoth object, or what is our class here? We're going to be passing in our player. That's our dot player, but our player class, if we take a peek at our player class, it does have a .x. So we are able to dive into that .x at least. So we go back to our scene here. We can say our player.x gets, and then this is where we have to put in, you know, actual smart code. So we'll skip that for now. But Shift X, if it's greater than 0, that's a shift right. And then if that's the case, then we would want to change our player X to be, and when we set our player X there, because there's two things. There's a player.x field, and then there's a player X variable that they're doing here. And I want to see where they do. See, the player X and player Y is different than a self.player.x. And you know what? Yeah, see, we're doing it wrong here. We don't do our self.playerx. We just do this player x because that's what we're tweening between our actual player x. So this x by itself here is actually in relation to the self.player table at its x field gets this new player x value for the tween. So I think that's how it works. So we got to not do this or this and instead put a variable called player x and set that equal to something smart. And then I think this is player x as well. And then if our shift y is greater than 0, which is a shift right, then we'd want to set our player y to be something. And then instead of just doing an else as a catch-all, I'm going to put in an else if just I guess we'll go for it. If it see, the thing is, like, we're doing so many new things here that if and when things crash, I'm not going to know where to even start trying to debug it because it's so many new things all at once. So for right now, we know that if we walk off the left side of the screen, that's going to instantiate a walk left, a shift left event that we're listening for to call the begin shifting function with the appropriate shift x values so that we can tween. So if we walk left, that would mean that our shift x would be negative, I think. Let me think. Because there's another thing, like if you translate it by a positive number, I don't know if it moves it to the left or to the right. We can check. We can check if I comment this stuff out. I wonder if we... Wow, I thought for sure we'd crash there. So what I want to do is turn on our shifting, not our shifting, our translating in our play state. I think it's in our play state. Yeah. So if we translate by a negative value, we move to the right, assuming that camera X is in fact a positive value. Let's see. It is 0. Oh. No, it is a negative value. So let's, for clarity's sake, we'll put a camera X will be a positive number, and then we'll just translate by the untouched number. So a positive number will translate it to the right. So I guess that is not backwards like I thought it was going to be. That makes sense to me. So let's go back to our... Where were we? Were we in our scene class, right? So we can go to scene and go to our scene class and harpoon it so we have access to it. And then let's continue on here. So shift left, that would mean that we walk left. Oh, see, and I think this might be a little bit backwards. Where I'm thinking is shift left might mean shift the next screen on screen to the left, like move the screen to the left so it comes on screen, meaning we would walk right to initialize a shift left. Does that make sense? Should we do it that way? Because I mean, I feel like that's what, if we give it a negative tween value, we would be turning our player X into a negative virtual width See, and that would be like a negative 300 or something on their game. So shift, if that's our shift X. You know what? Let's go dig around the shift X function just a tiny bit. So if we turn off all their shift X stuff, here we go. We turn off all their shift X logic, and we instead say, hey, shift X is gonna be, let's just say 50, and shift Y is also gonna be 50. And let's just see what that does when we walk off. It should place us once we're done transitioning at a 50-50, I would think. Okay, maybe not. Maybe not. You know what? I think maybe if we put... Where is our tweens? See, we're setting... Yeah, not here. We don't want it here. We want it where our tweens are, I think. So here's our tweens. So, okay, so what if we set... So what we're doing is we're tweening by our player X and our player Y. So let's put in... This is what we'll toggle off. And we'll say all of this is off. And instead, we have a player X that is 50 and a player Y. So what I'm thinking this will do is wherever our player initializes the scene change, it'll then tween its value from wherever its current position is to in X is 50 and Y is 50, which is like top left quadrant-ish. I'm thinking it'll tween over to that over the course of that 10 seconds because we have the 10 seconds here. So let's see if that's right, or let's see if I'm understanding that correctly. So if we'll go into the right door because I think it's going to move up and to the left to get to that 50-50 range. Yeah. Okay. And it's that 50-50 range of the screen that's scrolling of the current screen, not the new screen. And then we end up over here. Kind of where the 50-50 is. See how he's barely moving? Because 50-50 is just in that top leftish quadrant. See, and then we end up over here. So I think there's some other logic that's saying once we walk into a door, ignore your last X position, and you know that your X position is going to be tethered to coming outside the right side of a door in the future. So I don't think that's an issue. So tweening is kind of working like I thought it would. So if we go in this door, it should move up and to the left to that 50-50 spot. Yeah. So that's the player X and player Y variables that we're actually doing the tweening with. So ideally, if these values were correct, right? If these weren't a value that didn't make any sense, and we actually tween the values with an appropriate direction, then it doesn't matter that we're tweening in relation to our previous screen, because we're actually drawing it appropriately so that we would still see it by the time the transition ends. So that makes me feel a little bit better about this, but it is still very tough, because if we take a look at what they're doing, so and you know what, let's print out this shift X and shift Y and see if a left means a positive X because we're translating things to the right. I guess I want to see that. So if we go to shift X, in our dungeon render, we go love.graphics.print, And what we're going to print is the string Shift X, and we're going to concatenate that with our variable in string format of Shift X. And then we want to print that out at, let's say 5 or something, top rightish. Let's just say 0 0, just very top right. We'll print it. Hopefully we're at a love.graphics.set color of a white so we can actually read it. And I've got the white constant, but they don't. I think we have to give in the RGB values and the alpha. And then we want to print not only the Shift X, but we want to print substitute X for Y globally. Okay. Let's see, Shift X and Y should be on screen now, and we printed them up at the same spot, and we did the big font, so that was my bad. So let's do this at like 40 and see. We're still, they get set to nil. I gotta do a different font. Let me see where we do the fonts. We've got a medium font, we've got a small font. That is a small font. So if we pass in set font small, we should be able to just read these things. So we'll do a love.graphics.set font, and we'll pass in, we'll pass in the small font, and we'll see. They'll be nil until we initialize a, come on, dude. You don't like, oh, I think we gotta do G fonts. Oop. We gotta do G fonts at the index of small font, because that's how they did it. I believe. No? Dude, I was just looking at your font code. Oh, come on, where's... It's G fonts. Oh, just small, my bad. Just small. Just small. Okay. And the hearts are covering it. Mother... shit. Okay, we'll go... Let's say... 80. And 80. I'm just trying to see two numbers on screen, you know? Okay. Oh, they're so tiny. That's a small font. Okay. So let's see. If we go right, would Shift X be negative because we're translating by a negative number? And we're not updating it because it's in our shift. So what we got to do is put this, I think what we got to do is put this inside of our dungeon class, because that way we have to put it, if we're shifting, then go ahead and render this stuff, because it's just not updating. So now we'll do it in our shifting, and I want to make it a medium font actually instead. We'll make it medium so we can read it better, and then we'll offset the Y by more than 4, obviously. Okay. So now when we shift, I'm thinking that Shift X would be a negative number. Really? Nil. We're just not, it's just not working like we thought it would. If, like, where's our Shift Y, first of all? Like, we want to render this here. I'm just gonna spit this out. Like, why? Why? Why is it rendering nil? I mean, I'm not mad at that. That was kind of cool. But I didn't see any useful values of our Shift X or Shift Y, so... that wasn't super helpful to me. As far as next steps go, I mean, I guess we can let's just treat it as if we know what we're doing, and then we'll just see what works and what doesn't, and we can tweak it from there. So let's go to our begin shifting function up here. And we'll do somewhat similar player X and player Y values here. So this is a virtual width plus whatever our offset is, and this is virtual width minus player width. So we don't need to do that. I guess we can just do minus player.width. And then for our shift X positive, actually that was our shift X positive. So we can take that. If our shift X is smaller than 0, we want this negative virtual width. And if our shift Y is greater than 0, we want a virtual height. And then if our shift Y is smaller than 0, we want actually we did, negative virtual height. This is tricky, man. I couldn't tell you how to do this kind of stuff. I've got a reference I'm looking at and I can't quite figure it out. We'll do else if shift Y, else if shift Y is greater than 0. Actually, we already did that. We need smaller. Okay. So we've got our player X and player Y variables. So now we need to do the tween. So we'll do timer.tween. Takes in 2 arguments. We'll take in a 5-second timer, and then it takes in a table. Now the table see, and I don't know exactly why we got to do this. We have to, this is just part of the usage for timer.tween, is you have to say, hey, we're done with this function by the time we're done. But we're going to be modifying our camera X here, and that's part of our self table here. So we'll say, hey, that self table now gets tweened, and that dot camera X of our self becomes what our shift X parameter was when we passed it in over the course of 5 seconds. And then our camera Y gets what our shift Y parameter was over the course of 5 seconds. And then we need to keep track of our player, and we need to tween our player the appropriate distance as well. So we'll put in that the player.x here gets this new player X variable that we just shifted. We just assigned based on which direction we shifted. And then we need to add the listener functions so that we can actually detect that movement. So we've got those 2 things, and we're finishing out that tween function. So ours has a 5-second timer tween for our camera position for which scene to render, as well as our player position to move our player off to the next screen as we do that. Then we need there's this finishing shifting function that they're calling here, and we don't have that defined yet. So if we go and look at their code down here, they've got a finish shifting function down here. So they run the finish shifting at the end of their begin shifting function. Is that right? So they've got begin shifting, and then they've got finish shifting, and then I guess I'm confused why they would set the player's Y direction outside of the finish shifting function. I guess I don't get why they're doing that. Reset player to the correct location in this room. Okay. Okay. So what happens here is we're tweening the value off to the next screen, but that's not actually changing our player's actual location. So once it's done being tweened, and once it finishes tweening, then we need to actually set its X position to be the correct location. So we need to do some math here to figure out what that would mean for our game, because once we finish shifting, we would need, and then this is where they're doing all their, if it's a left shift, meaning this, if it's a left shift, set the player to face a certain, to be placed in a certain spot, and then if it's a right shift, we need to set the player to be placed in a certain spot. If it's a left shift, oh, and you know what? We just ran out of music. Instead of live coding the music like I normally do, I just recorded it and put it on in the background because I think it was just using too much CPU. It was making things laggy, so that means we're at an 1.5-hour stream is what that means. We shift left, that would mean shift Y is a negative number, and then else if our shift Y is greater than 0, shift Y is greater than 0, then we would do another thing. Now, our X position for our player is going to be dependent on, if it's a left shift, then we need to take our player X and we need to basically ignore what it used to be and set it equal to virtual width minus our player width, minus our self.width. Not self.width because we're in the scene function, so this is actually player.width. And then if it's a right shift, we need to take our player X and we need to actually make it to be virtual. I think I'm doing this backwards. If it's a shift left, we're going to be doing our X to be the right side of the screen. Yeah, so virtual width minus player width. Now, if it's a shift right, then we're just going to be a positive player width, I think. And then if it's a shift up, then we need to put our player.y up at the bottom of the next screen. So that would be our virtual height minus our self.height. And then if it's shift down, then we would be the top of the screen. So we would get our player Y gets to be a positive self.height. Yo, see you, Part Knocker. Thanks for tuning in. that's that. I think that's a good start. And then they've got a finish shifting function which resets their camera X. So we'll need something similar outside of our begin shifting function. We need our scene finish shifting function. And then would help if I spell function right. And then we would say we need to reset our camera X. So we set it back to 0. We need to reset our camera Y. So we set it back to 0. We need to swap our Boolean for shifting to be done. So we're no longer shifting. And then we need to set our current room equal to what our, and this, I think we have current scene, and it would be our, whatever our next scene was. So this is where we're making our current scene to be equal to what our next scene used to be. So depending on which side we walk off, that's going to lock in what the next scene is. If we walk off to the left, it's going to be same row, one column to the left. If we walk off upwards, it's going to be same column but one row upwards of our map table, our 2D array. And then we're kind of keeping track of those scenes here. And then they also reset their next scene to nil here. So let me just make sure we've got a current scene and next scene and that we're not imagining that. Yeah, we've got a current scene and a next scene. Okay. Now where do we first... we don't do it yet. Okay. So we've got to do this. We've got to set our next room. For right now, I'm going to set our next room to be equal to our map at 3,4. So we'll start us off on map 3,3 and we'll see if we can shift to the map 3,4. I'm 59 on scene is crashing. Why would it crash there? Because we're not ending this properly. Yeah, we are. This function is not liking something because this is blue and it should be dark blue. So what is it not liking here? Oh, I don't think we're finishing this timer tween function. Yeah? Huh. We are seemingly finishing that timer tween function. Let's see if debugging has any other info. So end parentheses around line 44. That wasn't right. 44. So it is the tween function, but what's fucking up here? We've got it typed out just like they've got it. I don't see the mistake here. Yeah, I don't see what we're doing different. Hoy, this is a lot to try to do in one day. This is just so much. It's all stuff I've never done before, so it's like extra tough. See how this function on the left is highlighting weird. Oh, well now that one's highlighting weird. Nope, that's our scene. Okay, I don't know how we did that. How did we shift our TMUX sessions over? Okay, let me just look. So theirs works fine. See, this is all we want to do. This is all we're trying to do, is just scroll. I mean, obviously faster than that, but... Scene 59. We're in our scene. Function. Begin shifting. Okay. I don't see what we're doing wrong. We've got that finish function. Like, I'm curious if we comment out this timer tween, will that allow us to not crash? Okay. So we're scrolling based on our translate. So we're messing something up here in our timer tween, and it might mean that we don't have a camera X for ourselves or camera Y for ourselves. But we do have a camera X and camera Y, and we do have a dot player. So why is it not working? We're doing literally the same exact thing. Just for shits and giggles, I'm gonna take their function and see. Oh, and you know what? It might be the indenting here. It might be the indenting. Because see how all of their stuff is indented here? Let's try that. We undo that. And we just indent all this. Oh, we're missing an end. Because if that's indented, yeah, and then we need an end there with a closing parentheses. That's what it's looking for. Yeah, okay. Okay. So I still think this is due to our translation function, not our tween manipulation, I believe. So if we go to our play state here and we go to the bottom, we can see that our translate is still turned on, and it is. So let's turn that off and let's see if it does anything. Okay, so what we're not doing is we're not initializing that event of walk left or walk up or whatever it is. So we've got to add that, and then we'll see how it crashes. So if we grep string here for event again, we can look for this event on. Now this is in the init function for the dungeon, so this isn't where it's actually being called. This is just where it's like declared. So we need to find event.on, I feel like. Whenever where do they do it? It wouldn't be in any of the lib knives. It might be in this player walk state. Dispatch, that's what we're looking for. So we'll take this event dispatch. That's what we're looking for the knife module. So let's just say if we're in the play state, then we're gonna go ahead and, how did I do that? We're gonna go ahead and event dispatch, and we'll do a shift left just to see if anything works. Anything shifts would be a success at this point. And then we'll worry about how to do it correctly. But I'm curious. Yeah, it's not shifting anything. Now, if we take a look at their dispatch, it's in their player walk state because they're determining whether they collide with the doorway. If their player collides with the doorway, then they're going to dispatch that event, and then that event goes ahead and initializes the tweening values based on the shift X and shift Y, depending on which event it is. And this is in their update function. So when we did we put it in our update function? We did. In our play state. Okay. Okay, well, what if we put it, I guess, let's just see if we put it in our player update function and see. Just put it here. We'll just go ahead and dispatch up. Nope. Doesn't do anything. Now, let's make sure we've got it declared right. So in our scene, we've got an event called shift, and it's shift up. Okay. Shit, man. Okay. I think what we're not doing is we're not rendering this scene based on its current scene. What we're doing is just making a global table for our maps and rendering that. But what we need to do is render this scene, basically. Because I bet if we printed up our shift X values, it'd probably be modified by the shift left dispatch, but we aren't actually rendering the scene. Sorry guys, I want to try to get the audio back. I don't know why the audio's not here. You guys getting any audio over there? Test, test. Okay. Sorry guys, we might lose the audio for tonight. Shoot, I don't want to leave the episode on such a I don't know what to do next. But I don't think we're going to be figuring it out tonight. I think the problem is we've got this scene, but we're not instantiating this scene anywhere. This is just a class and we're not doing anything with it right now. So we need to actually do stuff. Yeah. Good night, aka Bob. Thanks for tuning in, man. I appreciate it. You have a good night. We're not doing anything with this class. So if we take a look at theirs, they're actually instantiating this dungeon. We type in dungeon here. Oops. If we type in dungeon to our grep string, we will get where we instantiate it. And they're doing it right here in our play state. So see, they instantiate it. We're not even instantiating ours. So we need to do that. So in our play state, we need to say, hey, our self.scene gets a scene instantiation that takes in the player and the current scene. And then we probably need to move all our rendering for the scene into this scene class. So let's see if we can just do that. We'll go into our main state, or into our play state, and we'll go actually give us a self.scene. And this scene is an actual scene instantiation, which means we get the braces here, or the parentheses here, and we pass in our player. So we have access to the player because we need to tween it based on the player's X and player Y. And then we need to pass in the current scene, which at this point in time doesn't exist. We don't instantiate it till here, map 3, 3, and 3, 4. So we'll go ahead and put it here. And the current scene will get the map 3, and the map 4. And then instead of rendering here in our play state, we'd want to render based on the current scene. Instead of hard coding in this 3 and 4, we want to insert these tiles in our scene class and render them out in our scene class, I'm pretty sure. So if we take all this is in our init function. So we can go ahead and take that, go over to our scene, go to the end of our init function, and this is where we want that. And we actually might want it before. Yeah, we want it here. This in this main init function here. Okay, so we've got our map set, but we don't want here, we want our current map. So I believe we can put our current map here, which we have access to with self.currentMap. Current scene. Because if we take a look at this current scene, it's this current scene parameter, which is the second one. And if we see our play state here, we instantiate the scene with the map of 3. We should do 3-3 because we're trying to walk and change to 3-4. So now we just need to handle the rendering in our scene function, scene class rather, which is this stuff. So I think it's this chunk. We can delete all that code, all the commented out stuff. So we'll go to our scene, we'll go to our render, which should be empty. Yeah, it's empty right now, and instead of being empty, we're going to be rendering our current scene. Now, we are rendering based off of our tiles table, and our tiles table is set here when we instantiate it with the current scene. So maybe we can get something. Okay, we've got, did you see that? So something's happening when we press left, which makes me think that our left event thing is somewhat working. We're not rendering our table, our current table. So that's really jacked up. But we are having a shift left function do something weird. We're hard coding our next room. We're doing the tween, so I guess I'm just not... You know what? We're not rendering our scene. We got to render our scene. So we got to go into our play state, and we got to go down here, and we got to render our scene before we render our Kvolth. And I think it's self.scene. We want to run our render on it. Is that right? And then self-scene.render. No. What is... Oh, it's our current scene, right? It's self.scene. Self.scene. Self.scene render. Why does it not like that? We take that out, we don't crash. But if we have it in, we crash because bad argument 2, quad expected. But there's no it should just render this. It should render everything that's in here. Let's try not saving it as a self object, but saving it as just a current scene or whatever. So we'll say current scene gets that. And then when we instantiate the scene, we'll put it not in our self.scene, but we'll put it in our current scene. Bad argument too. Okay, welcome to programming. I don't get why... Oh, well, this is... The argument 2 is a table of map 3 of all the values. And then if we go into our scene, we're assigning our current scene into a dot current scene. And then, oh, and then we're not even rendering the dot. Let's see how we're saving the tiles in there. Yeah, we're saving the tiles as the dot current scene, but this should actually be the current scene at the index of count, I believe. Okay, so we're rendering our scene now. Okay, so we're not doing the tween values by going off screen, so we're not quite there yet. I want to say that we want to have a... Where are we doing our dispatch? I'm curious where we're doing our dispatch. Are we not doing it? What? They had dispatch in the player class. Dispatch. We don't have our dispatch. Did we set it? Did we set it in our play state here? In our update function, right? Where did we do it? Did we take it out? Let's go into our player and see at the top of our update function if dispatch is in there. And it should be event.dispatch, right? Yeah, we don't even have it. Okay, so what we're gonna do is if left was pressed, we're gonna go ahead and event.dispatch. And what we're gonna dispatch is our event function, which is shift left. I think that's right. It doesn't seem like we're doing it. Okay. Well, at this point, I'm not sure how to test it. Because we can't even get our... Unless our dispatch function or our event listener was different. Let me see what our event listener, it's called shift. Yeah, it's in our scene and it's just a shift up, shift down. And it's an event.dispatch. So if we go, let's just say, hey, in our main state, we're gonna go ahead, first thing we do when we update, actually when we init even, we can just say event.dispatch, and we're gonna do that. And it's gonna be a shift left. Oh, we did it, we moved. We freaking moved. Huh. So shift left actually did something. Shift right crashed. Shift up is actually working. Shift down is working too. So in our dispatch function, we did something jacked up with our player X function. So we'll just make sure we go back to that. That's in our scene class. And our shift right function is doing something jacked up with our player X. So if it's a shift, player X gets Player width. Okay. I don't see why shift right is crashing like that. Okay. If we go back to our main, this is exciting that something's working. We're not shifting our background like we want to, but we are shifting our characters. So that's at least a start. Shift right. Let's see what it says when we try to shift right again. It says, attempt to index global player, a nil value on scene 42. So if we go to scene 42, player X gets yeah, we don't have access to player, we have access to self.player. So we'll do that. Self.player.width. Now we're shifting right. So and then we crash for whatever reason. We're not shifting, we're not tweening our background values because we're oh, you know what? Yeah, because we're not rendering the background based on our camera X and camera Y, which we should be. So instead of drawing these, we have to translate by our camera X and Y. So we would say, we would say love.graphics dot translate gets a camera X translate and a camera Y translate. And then it'll draw the sheet at the camera X and camera Y, and maybe it'll move. Shit. Okay, translate at argument 2. You don't like argument 2. You don't like camera Y? We get a camera Y. Oh, self.camera Y. Okay. So we just need to do it at self camera Y, self camera X. Oh my god. That's money. That's money. Okay. So that's shift right, which shifts it to the right. I kind of want to rename them to be like transition, right transition, and that'll move things to the left. Does that make sense? Like if we go off the right side of the screen, it's a right transition, meaning it'll come from the right onto the left. So I think we want to change this wording to be right transition. That makes more sense to me, because the right transition would mean it comes in from the right. I think that makes more sense. And then we need to change the actual math of it so that that is the case. And then we need to worry about the event dispatch only working when we're in the specific zone of us walking all the way to the left or whatever. So we'll go into what? And you know what? I'm wanting to get music back for y'all. Can you guys hear it? Oh, music is going. Music is going. Okay. Let me just turn it up a bit then. Okay. Okay. So let's go back to our scene and we'll go into our this stuff. Now, shift left is going to become left transition. Shift right is going to become right transition. Shift up is up transition, meaning the next screen is going to move down into frame. and then down transition. Now we need to put the actual right arguments in here. So a down transition would mean that there's a y of a positive height. Does that make sense? Let's see if down transition translates to downwards. Or down transition would mean the screen moves up to replace. Hi, is that confusing? Because down transition currently means we move it down. But that would mean we are walking up because the current scene would move down. So I think we want all these kind of flipped. We want in our scene, I think we want down to be up to be down, right to be left, and left to be right. And then let's see, if we do a right transition, that would mean that the current screen, the current scene is going to be moving to the left. Nice. Cool. And we are getting some weird artifacts there. So now instead of doing this event dispatch here in our main where we just do it, I just deleted our buffer there. We'll go into our player class and we'll say if right is no. At the end of our update function in our player class, we're just going to say if our player, it's going to be self. If our self.x is greater than the virtual width minus our own width minus like maybe 3 pixels, then that's when we're going to event dispatch this right transition. So this is hopefully going to initiate that right transition once our X position is close enough to the right side where we're almost walking to the next screen. So it stays fine until hopefully we walk far enough here within 3 pixels. Yeah, and then it starts the transition. So our values are fucked up, but that's okay. Because we just want that to work, right? So if we go, it's nice that it's doing something. So I feel good about that. I guess for now, we can do the other event dispatches, like if our X is smaller than it'll be smaller than a positive self width plus 3. Yeah. If it's smaller than that, then it's going to be a left transition. Let's try that. Nice. Yes. So we're not rendering the new screen just yet. We crash when we go off, but at least we've got a left transition and right transition starting to work. So it looks like our player X is getting tweened way too fast. Let's go ahead and add our other dispatches here, just to kind of keep an eye on the testing for it. If our Y is smaller than smaller than 3. 3 is the amount of buffer we're giving it before we dispatch. And we're going to dispatch and if we go up, that's going to be an up transition, which actually moves our screen down. But that makes sense to me. Calling it up transition, because we walk up, that triggers the transition, and that will move the next screen downwards into view. And then if our self.y is greater than the virtual height minus our self.height, and then also minus that 3 pixel buffer, then we're going to go ahead and event dispatch the down transition. Transition. Yep. Okay. Okay, let's see if down transition works. Oh, and you know what? We've got to minus the offset for our little thing there. We've got to also do our, what do we call it? What do we call it? It's in our constants. It's called a off-screen, no, screen height limit. That's what it is. So we'll also minus a screen height limit, and then also a -3 for our bottom. Oh, yep, not quite, not quite, not quite. If our y is greater than, okay, y is smaller than 3, we up transition. If y is greater than the virtual height minus the screen limit minus the self, okay. I guess I don't get why that's just automatically going off. Why do we automatically go off? If our y is greater than our virtual height. Okay, so we're missing something here. Maybe our screen height limit. Oh, okay, no. Our screen height limit is virtual height -16, so we can just replace that. So we can just say smaller than screen height limit minus self.height minus our 3. Okay, let's see if we trigger that bottom transition here when we're coming up close to the bottom. Nice, 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 dude. Yes, animation still works. We're still scrolling that. Now we need to go into our scene tweening for our player X, and we need to make sure that's better. Because remember, we just put in dumb values here for our player X. So let's take a look at our transitions here. Okay, so now if our shift X is smaller than 0, that would mean it's a right transition. So if it's a right transition, then we need to move our player X to become the left side of the screen by the time we're done tweening. So that means our player X would need to be the left side of the screen, which is just 0. So let's see if putting a 0 here helps move our player to the left side of the screen for a right transition. Let's see. So right transition, we're hoping Kavoth will slide over to the 0 position on the left. Okay, and we're not setting his shit. Okay, we're not setting his X value appropriately here, because we need to set right here. We need to set this to 0 if we're doing a right transition once we're done shifting. And then maybe that's the case. Okay. Shit, we keep going. What is... All right. Okay. Let's keep tweaking this. So shift X greater than 0 is gonna be a left transition. So if we're transitioning left, that means the screen's moving from the left to the right. That means we need to end up at the right side of the screen. So our player X needs to end up, yes, at the right side of the screen, which is virtual width minus player width. Okay, if shift Y is positive, then that means we are doing an up transition. That means we walk up and we move to the bottom of the next screen. So that means if self.y is greater than 0, then we need to end up at the virtual height, and it's actually not virtual height, it's actually screen height limit minus our self.height. So we should end up at the bottom if we go up. Oh, 44 field height. Self.height is actually self.height player.height is what it is. Okay. Hey, thanks, Salto Manga. We're getting there. We still crash. Let's see where we crashed there. We crashed there at 95 on the player state because y was a nil. So player state at, I already forgot the code. So we've got player state 215, player class 215. So we're in player. Let's go to 215 and just see why y became a nil value. So we might be upon the finish transition, we might be only modifying finish shifting. Oh, we don't. I don't know. I feel like if we set our player y here, it's a little redundant, but it might stop it from crashing. Like, let's say, no, I don't know. We should set self finish shifting. We run that, and then we set the player's X and Y position. Okay. Now, just for experimental purposes, if we say self.player.x gets 0, and we also say that the player y gets 0, not what I wanted, y gets 0, do we still crash? If we explicitly tell it it's not nil. And it finishes, okay. Okay. And then we crash, because field height is a nil value. So scene 61 is crashing, and it's because that this self.height, okay, yeah, that's a self.player.height, that was my bad. And it's not a player.width, it's a self.player.width, and it's not a self.height, it's a self.player.height. Because we're passing in our player character into our scene state, so we have access to it. Oh, that's cool. That's cool. Do we crash? We don't crash. And it initiates the next... Oh, man. Okay. All right. I will say it's not exactly right at the moment. But we're not crashing. So now we just get our camera offsets working right. Okay. All right. Let's see what we can do. So, I guess, what do we want to see? We really do want to draw we want to draw all of the next grid. So let's try to do that. If we can get the next grid working and it's still messed up like this, at least we're scrolling and at least the next grid is there, right? Oh no, the stream's crapping out. Sorry guys. I paid for better internet, but the stream's crapping out. See, we've got a next room. Now we're not rendering the next room. We can go ahead and do the same kind of thing here. So here we put in all of our tiles for our current scene count, which our current scene gets passed in this here. Okay, so if we have our next scene, we can save this map as our next scene, which we are in here. I'm thinking we can save this next room here, and it's not next room, it's next scene. And this depends on which direction we kind of trigger. For right now, I think I want to put map 3-4 as our next scene, just so we can try to get it rendering. So map 3-4. That's going to be our next scene. Now we need to put in, and this is going to be messy. I'm just trying to get the next scene to render here. So we're going to input the ID of our map, actually of our self.next scene at the index of count, so that hopefully we've got all those indices of our next scene in there. And then we need to render all of that stuff too. And we need to render it only if we're shifting. So what we can do is say, I think we want to say if self.shifting, then go ahead, do all this stuff, which is render, actually, hold on. Camera X gets set to 0 so we don't draw it. Okay, so maybe if we're shifting, we want to say, just render our new one, and then render our old one at the right translate. Let me copy this. We'll say if we're shifting, we're gonna render not oh shit, we're doing this to the same table too. We need a separate table. Shoot, man. Right now we're putting it in the tiles table here, which just overwrites our last one. So we need another one. So, and we should move our tiles into this class anyway. So we need, like here, tiles and map, count, all this stuff. I think we need this over. Actually, yeah, let's just go ahead and do all this in our scene class. Okay, so there's our maps. We're giving a current scene, and this is wrong. This is, we want current scene. We can reset our self.current scene. Oops. To be this. Now I'm wondering if our current scene here was being rendered anywhere. No. Okay. Do we just crash? Camera X is a nil value. That's in our play state, I believe. Oh, okay, so we do need camera X in there. So let's go ahead and give that back. We don't need this anymore. Okay. 69 play state. Okay, I guess we can render our current scene. Shit, man. It's so hard to think about how this needs to interact with itself. Because if we render our current scene, our current scene render was just all of this stuff. So we actually don't need that line anymore because we're rendering it here in our actual scene. No, we need to render the instantiation of our scene. So we need our shit. This is getting out of my pay grade. I mean, this has been out of my pay grade. We need that current scene render, and we need to actually instantiate this scene, which we should do here, and not as, come on, dude. This scene instantiation we need to put here in our play state. And it can be this current scene, and then when we render current scene, we have access to it. Great. We need map to be outside too. God dang, dude. It's... See, like, this is what sucks about refactoring, because once you, like, break stuff, you're just so stuck. Like, you gotta remember where you moved everything. You gotta remember how it used to work, how you've messed up implementing it. And you know what? I'm gonna say map and tiles are now local to here. But I don't know if that's gonna mess everything up. And then we'll give us a, I guess another local map and tiles so they don't interact each other. Play state 12 we're messing up, and it's because .12 is here because we try to do map before we have a map, so we'll put map there. And yeah, we can't index a map without the... God dang, dude. Well, why do we need... I'm gonna have to really think hard about what we're trying to do here, because this is just really difficult. We need to put... Let's just, for now, we'll put our map back. We'll put our map 3, 4 back. We'll keep them there, but we'll put them here so we have access to it, so we don't crash. And just try to get things to render again, because playstate 26 is crashing now. Now, it doesn't have the 2D array because we never added it over here, so we need to... Oh my god. Okay, so we need to insert an empty table into the map, and then we need to... We'll just worry about 3.3 right now. We'll say, hey, 3.3 gets an empty table. Actually, we can just sign it there. Oh my god, man. Scene 6 now. And then we'll do that after we actually have that map, so it knows what I'm talking about. Oh my god. Dude. Scene 133. This is just ridiculous. We need to really figure this out. See, tiles doesn't exist. See, tiles exists here and we just put it in. So... You know what? We're gonna undo until it works again before we moved all this stuff out. Let me just see if that works. I shouldn't have saved it. I should not have saved it. Okay. Bad argument 1 in our scene 24. Okay, we don't have our tiles table. I thought it was global, and I thought it was here in our play state. Well, it is not global. We made it local. Okay. Yeah, we're gonna have to do some hard thinking about what atrocities we've done here today. 29 scene, we're crashing. We don't instantiate our count, so we'll just say count gets 1. Okay. Well, we're back to this, which I'm gonna have to make a mental model of exactly how we want to do this. Because we've got a 3-dimensional array of map sprites. So like right now, our map table is a 2D array of potentially this many number of sprites tile codes. So that looks like this. In our scene. And actually we took them out, we took them back in play state. So this is what our map table is. But in order to render those, we need to keep track of the index. So that's where the 3rd dimensional aspect of that index goes. So since we're sharing data between our play state and our player state, and our scene class, it gets really messy because Lua has only access to certain variables at certain times, and I'm just getting everything mixed up. So I think right now is a decent stopping point to just say we've got some scene transitions working. They're not working properly, but you know, we are actually scooting, which is a plus. And then once we figure out how to mentally model this stuff, like what kind of class object do we need that can maintain a reference to this original map while rendering the original map, while keeping track of what event is being listened to, how we're translating that, and translating the next room as well, and a reference to that next room, and all its indexes, and the rendering and insertion of all those indexes. Once we kind of mentally map how we can store that, then we can refactor all of our mess right now and hopefully be in a better spot to tweak all of the tweening. Because we can take a look at our tweening here in our scene, and we can go faster. Like we can go more like the game is gonna be, which is faster, like 1 or 2 seconds. Yeah, I mean we go really fast. It would probably be even like 1 second. But we're not resetting our camera X position. We're not yeah. Oh my god. I like the disco mode, but once we figure out how we reset, you know, we need to reset, and we're resetting our camera Y, but we're, yeah, and you know, we are translating by the camera X and Y, so I don't get why we're shifting it and then shifting it back, and I'm not so sure why that's happening. So I don't know if you guys want to see me stumble through that more. I don't know if that's part of the appeal of this channel, to be like, hey, I'm confused too, but if you figure it out, it gives me hope. But I'm definitely going to chew on this and kind of try to mentally visualize how we can map out all this data and then refactor it into something that makes more sense for our game, because I'm looking at their code that they do for this dungeon, and it's just different than ours. Like, they've got a big old border around it. They're doing a bunch of entities that we're not worrying about right now, and they've got different I don't know. It just feels different on theirs than it does on mine, and we can't just do exactly what they did. So yeah, so Salto Manga, this is like, you know, I love watching game programmers, but when I'm watching them, I have zero idea what they're doing, and I'm sure a lot of people watching me have zero idea. I don't know what I'm doing, but that's kind of the thing. It's like, if you guys see me stumble through it, you know, maybe you guys can stumble through it too, because I've been wanting to make games for years and never just sat down to do it. And now I'm doing it, and it's not easy, and it's not so glamorous all the time, but when it works, it's amazing. So I would just love, you know, I would like the idea of someone stopping by stream, saying hi, and then, you know, 3 weeks later they see that I've made so much progress, because, you know, we've only started this game like 2 weeks ago. I started streaming it on Twitch maybe 2 weeks ago, and we've got fully messed up scene rendering already, so that's pretty impressive. But yeah, I'm having fun doing it. We got more than I thought we'd get done today, and we streamed longer than I thought we would, but we're making progress, and I'll catch you guys tomorrow streaming, and hopefully I'll get a better idea how to tackle this, because this is a mess right now. So I want to kind of tame it down, know what I'm working with, so that I don't get so lost in the weeds, because we want this core of the game to be rock solid, so that all we have to worry about is the level design, then the entities, then, you know, we just need the map to be out of the way, working, not broken, and makes sense if we need to do any small tweaks. But that's the struggle. So I do think that this is probably like the hardest part of the game, because I've done collision detection. I know how that works. I've done, you know, particle emitters. I know how that kind of works. I've never done scene scrolling on a scale like this, or tile rendering based on sprites instead of the whole, you know, instead of the whole background or whatever. So this is a great learning experience. So thanks guys for tuning in. I really appreciate it. I've got a friend programming right now on Twitch that I feel like I can raid out to, if you guys are down. And if you want to just say hi, he's working on a video game like Celeste, and he's building it in the Godot game engine. But if you guys just stop by, say hi, I know he really appreciates that, and he's a cool dude. So I'm gonna see if I can't raid out here. I need a button that just raids out quickly for me, because it's taken me 12 seconds to find the button. So yeah, if you guys are still here, I'm gonna raid out to Practical NPC, but I will catch you guys tomorrow for another stream. So thanks for watching, guys.